Today's lesson is 8.6 on trapezoids. Trapezoids, as you're familiar with, are quadrilaterals, and they should look a little bit different than what we've been studying so far. The definition of trapezoids might explain why. It's a quadrilateral with exactly one pair of parallel sides. So as we trained ourselves to ask when we're encountering a new quadrilateral, I'm curious to see, is this a parallelogram? Well, given that the definition of a parallelogram is a quadrilateral with exactly two pairs of parallel sides, clearly a trapezoid is not a parallelogram. So all that information we know, all the properties we know for parallelograms do not hold necessarily for a trapezoid. That's an important point to make. We just talked about squares, and they're kind of the king of quadrilaterals, I suppose. Trapezoids are a different breed. There are several parts here that we need to take note of. Perhaps the most obvious would be the two bases. They are the two sides of the trapezoid that are parallel. The other two sides are called the legs. We speak of the angles as pairs of base angles. Segment TR is a base, and there are two angles, angle R and angle T, that are adjacent to this base, and therefore they are a pair of base angles. Similarly, angle P and angle A are a pair of base angles. And one thing that I want to do real quick is just draw a couple of other trapezoids that you might associate, another couple of shapes that are also trapezoids that look slightly different. Okay, we have some like that, where we can't have right angles here. That's okay. It's still a trapezoid if the top and the bottom, or if you spin it, the left and the right are parallel. Another trapezoid might look like this. This is an unconventional one. You didn't see many of these in elementary school, but it's still a trapezoid. It's just funny looking, I suppose. Okay, there's really nothing else to say about regular trapezoids, similar to the fact that most quadrilaterals aren't really that special. The only thing special about a trapezoid is that one pair of its sides are parallel, unless both its legs are congruent. This is called an isosceles trapezoid. We know the word isosceles from triangles. Two of the sides are the same. Well, the same is true here. A trapezoid with congruent legs is an isosceles trapezoid. And there are some interesting things. So, of course, by definition, the two sides are the two bases that are parallel, and the two legs are congruent. In addition, you can see that the diagonals, which I've drawn here in red, the diagonals are congruent to each other. Just as you can see, you can look at a rectangle, visually inspect it, and kind of conclude that the diagonals are congruent. Such is the case for isosceles trapezoids. In addition, both pairs of the base angles are congruent. Again, this is something that's fairly easy to see. Angle S and angle C are both obtuse angles, and as it turns out, they're actually exactly the same size. The same is true also of E and L, which in this case are obviously acute angles. You must be careful when encountering a trapezoid not to assume that it is isosceles, even if it looks to be isosceles. You must always either prove it yourself, or you must be given the information. Okay, so time for an example. Shown here is a quadrilateral that they tell us is an isosceles trapezoid. So the first thing I can do is, I know it's a trapezoid, and obviously these are the sides. Obviously these are the sides that are parallel, and that means that the other sides, the legs, as opposed to the bases, are congruent. Okay, and remember, we're already thinking two different things here. The diagonals are congruent because this is an isosceles trapezoid, and also the base angles are congruent. They want to know the measures of the given angles and segment HN. Well, let's start with the angles. If angle N is 66 degrees, the other base angle, its pair, that makes up the pair, is 66. That would be angle U. 66 degrees. Now we've got to find angle S and angle H. It's important to remember that these, the sides, the bases that are are parallel, and therefore angle H and angle U are consecutive interior angles, which we know to be supplementary. I'll save you the writing here. That means these two add up to 180. 180 minus 66 is 114 degrees. And because S and H are a pair of base angles, angle S has to be 114 degrees. So that's simple enough. Now we have to find the length of segment HM. Well, again, because this is an isosceles trapezoid, our diagonals are congruent. So that means HN is equal to SU. Doing a little bit of arithmetic here, SU is going to be equal to 18, 19.1, and that is also the length of HN. Straightforward. Okay, we've been working on this all chapter since we first did tests for parallelograms. If we're given 4 points, it says they tell us that it's a trapezoid. We need to verify it. That is, we show it. Well, we ask ourselves, what exactly is the definition of a trapezoid? And we remember that it's a quadrilateral with exactly one pair of parallel sides. To show that, I need to find the measure or the slope of all 4 sides and show that one pair are parallel. The others should not be parallel. So the 4 sides, and again I'm finding the slope of each. The first side will be XM, and also we have MP, we have PL, and we need to find the slope of XL. Okay, I'm going to consider the slope is the change in y over the change in x. So I look at x and m, and I consider the change there. -1 minus 1 is -2. And now the x is -3 minus 5 is -8. That simplifies to 1/4. Okay, I suppose the next one is MP, but I'm a little bit anxious. I'm going to go and check PL because I know it's opposite. It's only opposite side. So let's go and check that out. The change in y, 4 minus 3 is 1. Over the change in x, 2 minus -2 is +4. 1/4 and 1/4. I've got one pair of parallel sides, so this appears to be a trapezoid. I have to check, however, I have to check the other two just to confirm that it's not a parallelogram. So let's find those slopes. MP, the change in y, 3 minus -1 is +4. -2 minus -3 is +1. So here our slope is 4. So we've got 1/4, 1/4, 4. Okay, and pretty much as long as the slope of XL is not 4, we know that this is a trapezoid. All right, XL, the change in y. 4 minus 1 is 3, and 2 minus 5 is -3. 3 divided by -3 is -1. So we have one pair of parallel sides. Indeed, it is a trapezoid. So I'm just going to draw a little trapezoid and put a check mark next to it. Okay, part B says, this is part A, part B says determine whether it's isosceles. Well, again, an isosceles triangle is one whose legs are congruent. So I'm just, for the sake of making this easy on myself, I need to label this XMPL, and it's important that I realize that XM is a base and PL is a base because they're parallel to each other. So PL, it was XM, PL. Okay, I know these guys are parallel. So the legs, the ones that should be congruent, are XL and PM. So we're going to check those out. To see that they're the same length, we need to use the distance formula. So MP, square root of, okay, I've got the change in x squared. So here's M and P. The change in x from -2 to -3, they're just 1 apart. And now the change in y, -1 and +3, they're 4 apart. So this is equal to the square root of 17. No need to bother approximating this. Now we're going to do the other side, which is XL, the square root of. I need my change in x's squared. Well, 5 and 2 are 3 apart. Plus, let's get the change in y's. 1 and 4 are 3 apart. And 3 squared plus 3 squared is 18. These are really, really close. In fact, if you were to graph this on a coordinate plane, it would probably appear to be a congruent trapezoid. However, we've looked at the numbers, and although close, it's clear that it is not a congruent, not an isosceles. And I'll say because we know that MP is not congruent to XL, or equivalently, MP is not equal to XL. Okay, A definition now. The median of a trapezoid. In this situation, the median is segment ER. We take a standard trapezoid, it doesn't have to be congruent, and we essentially draw a line right down the middle of it. Okay, by definition, this segment joins the midpoints. So this is the midpoint, R is the midpoint because these two parts are congruent. E is the midpoint because these two parts are congruent. That's all we know by the definition. But it's pretty clear, again, we can visually inspect and see a lot of this. This middle segment, this mid segment, or the median rather, is parallel to the top and the bottom. And moreover, its length is the average of the short base and the long base. The easiest way I could think of to write it would be this way: 2 times the median is equal to the sum of the bases. We should do an example with that. So here we have a trapezoid herd. It's isosceles, they tell us, and SP is the median. First, it says find RD if HE is 20 and SP is 30. So HE is 20, SP is 30. Again, SP is the median, and it is the average of the other two. So which is to say, it takes 2 of those, 2 times SP is going to equal the sum of the bases, HE and RD. Well, we know that SP is 30. We know that HE is 20. We simply have to find RD. 2 times 30 is 60. If I subtract 20 from both sides, I find that RD equals 40. Easy enough. Now, for part B, it says find the measures of all 4 angles in the corners. If the measure of angle 1 is equal to this, and the measure of angle 3 is equal to this. Well, let's see how 1 and 3 are related. This is an isosceles triangle, an isosceles trapezoid, which means each pair of base angles is congruent. Okay. Moreover, because it's a trapezoid, I know that these guys are parallel, and because they're parallel, angle 2 and angle 3, which happen to be consecutive interior angles, are supplementary. That is to say, the measure of angle 2 plus the measure of angle 3 equals 180. And I don't know, they didn't give me any information about measure of angle 2, but they did tell me measure of angle 1 is equal to 3x plus 5. I know that 1 and 2 are congruent to each other. So I'm going to replace angle 2 with angle 1. And at this point, I'm just going to plug in the information they give me. Angle 1, they told me is 3x plus 5, plus the measure of angle 2, they said 6x minus 5, equals 180. That's 9 x's and 0 constants. Divided by 9, so x equals 20. Okay, they didn't ask what x is, they asked what the angles are, so I'm going to plug it back in. If x is 20, then 3x plus 5 is going to be 3 times 20 plus 5. That's 65. Angle 2 has to be the same thing. And because angle 2 and angle 3 are supplementary, angle 3 has to be 115 degrees. Because 3 and 4 are a pair of base angles in a congruent trapezoid, an isosceles trapezoid, they have to be congruent.